All right, so today we have my friend Jeff Jonas. He is the founder and CEO of Senzing, a startup focused on democratizing entity resolution, specifically to make this complicated task for programmers easy. So, Jeff, welcome to the Data Exchange podcast.
Hey, thanks. How many of your viewers do you think even know this word entity resolution? What do you think that is? 30%?
I
50?
think
20?
most of them know what it is once we describe it, maybe not the exact phrase. So let me just give a quick definition for our listeners. So this is connecting disparate or different data records that represent the same real world entity. So an entity could be something like a customer, a product, company name. And then actually, Jeff, I've been meaning to ask you, there's a related term that people use called master data management. Are you familiar with this term?
Yeah, of course.
Yeah, and it seems like kind of like entity resolution is what it is. It's a much more descriptive term, but master data management, obviously, probably entity resolution is a subset of that because it's not just entities that are part of master data management, but it seems like when you look at the term master data management, it's kind of like entity resolution.
It would include it. You know, one of the ways I describe it to folks is we build transmissions, not cars. So KYC, know your customer systems, anti-money laundering systems, patient healthcare record systems. Those all need, transmissions, or in this case, entity resolution. MDM, it just turns out that's a big chunk of what MDM is understanding who is who in the data.
Yeah. And one of the reasons I wanted Jeff on this podcast is because entity resolution is kind of one of these first order tasks. So you have to do it because all your downstream applications and models suffer. It's the classic garbage in, garbage out. If you don't do this well, then everything you do after that suffers. And it's also become entity resolution is a class of software that I've now include in my don't try this at home list. and honestly, it's also one of these things where if you have a simple app, maybe where the stakes are not as high, you can build something hacky. You can do something, but if it's something that if clean data, high quality data is fundamental to what you do, then I think it's going to become clear to you listeners after this episode that this is one of these don't try this at home pieces of software. So with that long-winded intro, topic number one, Jeff, of why this is challenging, accuracy. So it turns out, and I do this myself, and I do entity resolution, right? So you get a certain level of accuracy, and then you can't do much anymore unless you really kind of either go in there and clean up the data or do a lot of rules and things like this. So maybe explain to our listeners at what stages of this entity resolution pipeline does accuracy really kind of become super challenging?
Accuracy at scale becomes challenging because if you have 5 records, you could exhaustively analyze all of those records. You can do it all in memory and it's no big deal. But as soon as your data sets grow and you've got millions, tens of millions, hundreds of millions of records or more, then it gets a little harder because you can't check every record against every record in any kind of an effective way. And organizations are trying to do 2 things. You're trying to figure out how does the data we already got relate to itself? Are there duplicates in our data? Or how does the data in this silo relate to data in that silo? So duplicates this way, matching this way. But then they were also trying to figure out as new records arrive, how do those records relate to all their other data they've got? So you've got this historical start problem. And then you've got how does, transactionally, what's going on with who's who? And to do that with accuracy and scale is the hard part. Then it just goes down into the weeds, you know?
Yeah.
Weeds.
And then Jeff, there's also multiple languages,
Yeah, there's different.
multiple, and then multiple ways of writing the same thing, like a phone number, address, or social security number, right? So
Yeah. I call that natural variability, you know, nicknames, somebody, Dick or Richard or Rick could be natural variability. One address says Avenue, the other one says AVE, the other one doesn't have anything, or it says street, it's a boo-boo, but it's not an important part of the address very often.
so set aside for now, let's set aside the latency and real time.
Mm-hmm.
Let's focus on accuracy. So some of our listeners might naively say, Jeff, that well, now we have these beautiful things, magical things called LLMs and vector embeddings and vector search.
Mm-hmm.
So assuming those are performant and it can handle scale, that's using those, can they miraculously get rid of the accuracy problem in entity resolution?
Well, these are different kinds of muscle groups, I will say, right? Different kinds of tech. I'm actually in love with LLMs. I think they're phenomenal and they're going to do all kinds of exciting things. But as a backstory, if you ask, let's say, ChatGPT about Jeff Jonas and where's my logo? Iron Man.
Yeah.
It depends which day you ask it. It's going to think I helped inspire the movie or the character Jarvis when I have nothing to do with it. These LLMs, are fabulous at crafting accurate sounding things. They're creative and qualitative, not so much quantitative. People using entity resolution need to get the same answer tomorrow. Because if you're going to make a big decision, you better be able to explain why you got that answer, and it better be the same tomorrow and the next day. And so I think LLMs and entity resolution AIs are going to work in harmony. You could call it an antipsychotic or an anti-hallucinogenic, and you will insert into your LLM, there's not 3 Jeff Jonases, there's 1 Jeff Jonas. Here's the 3 products that Jeff Jonas has. And then the LLM will help craft maybe really good speaker notes to, the person that's going to take the customer service call, an outline, about what's the best recommendations for them. So there's going to be a harmony between the two.
What about, Jeff, vector search? Because let's say, there's multiple ways of writing the same phone number or same address or the same person with nicknames, misspellings and stuff. Vector search is supposed to help me find semantically similar things. So would vector search miraculously solve my accuracy problem?
No, but it might contribute to being able to search back and find records that should be considered for matching, especially vector databases. I think there's maybe some exciting nexus between vector databases and entity resolution. We'll have to see how those scale. An important aspect in entity resolution is you can do a one-time batch run and get an outcome, and some people need that. But most of the types of organizations that at least we see what their needs are, they want to be able to do entity resolution in real time. They want to know when a new customer is signing up, if that customer is already in the database. And if they sign up and come back 3 minutes later on another channel, they want to realize they've already signed the customer up.
So this is one aspect in the vector databases are still working on all of this kind of. They tend to be a little more batch oriented right now, but at some point,
isn't one of them though of these vector databases doing transactional?
Starting to. So
Yeah.
this is an emerging capability. So at some point, maybe it becomes more mainstream. So do you think at that point, vector databases become part of the ER stack?
Maybe.
Yeah.
Maybe. we've kind of, in the old days, we used to, ER used to be a stack, but now we've compressed our generation 6 into a shared object or a DLL that just sits on top of a database. So the stack is a programmer library, an SDK, and a data store. But what might we find a vector database performing some of those database tasks? The index that's preserved, so that you have the same persistent key tomorrow or the next day? Maybe.
So what is more challenging, Jeff? I guess these are related things, right? So scale in real time. So if someone were trying to do a entity resolution system from scratch, which we do not recommend, where would they end up being more frustrated?
I'll tell you what the actual hardest thing to do is as you're loading records, let's say you've loaded 100 million, now you're at record 100,000,001. It's not uncommon that new record you've just learned inspires you on making a better decision in the past. You may decide that you thought they were the same people, but this new evidence, record 100,000,001, actually informs you that was a junior senior. We spent years noticing this and wondering what to do about it, and then years, millions, to have that new record fix the past. You see, if you don't do that, what happens is your database becomes inconsistent. You look at the records that have landed, and you're like, why did we make that decision? It's so obvious it's a junior senior. And the answer is, oh, that record came late. So I call it sequence neutrality. Did you get record A first, then B, then C, or record C first, then B, then A? And what you really want is no matter what order the records arrive, you get the same answer. That's hard. That's really hard. And if you don't do that, your database, you're losing, let's say 1% of accuracy a month, or maybe every single night you're going and taking the system offline and doing a reload of everything. And then you have to have an A system and a B system. So having a system heal itself, being real-time, an AI that is real-time learning and real-time tuning and real-time fixing the past, is non-trivial.
So as you were speaking there, I was trying to parse. So to what amount of the ER challenge is a model problem, ML model, or a systems problem?
The feature comparators are more of a model problem. And I'll give you an example. Addresses are really messy. And if you want to compare addresses, you got to first parse them right. But they're all out of order. They're a mess, generally. So you want to run those through a model. The model we use, libpostal, is a great open source project. We've been making contributions to it now for some time. That model's trained on OpenStreetMaps and other sources so that you can give it a messy address and it'll parse the pieces into the right buckets. That really helps. Then you score the address, then you insert that into the system. So comparators, like our name comparator, has been statistically trained on 850 million names. So you want those models in each, maybe I'll call it context-aware comparator. Sometimes, by the way, this is about how hard how hard it is I'll find somebody that's in the entity resolution space and they'll say something like they used to use edit distance, like Levenstein, on every feature, dates of birth, names, addresses. Can't do that. If you want to have accuracy, the way you compare addresses has to be very particular. Right? 4-character Chinese name with 4 vowels, you're going to compare entirely differently than a Russian name in Cyrillic. So you have to be culturally aware. You have to see what culture the name is, the script, and you have to compare it particular to that. And just to go on about this, by the way, is like our social security number comparator knows what social security numbers were used on billboards in the 70s for advertising.
Wow.
That's not a good social because it's been marked as invalid since it was used for marketing.
So I suspect a modern entity resolution system that you're going to sell to an enterprise, and most enterprises are global companies, will need to be able to handle multiple languages, multiple character set,
Yes.
right?
Yeah.
That's basically a requirement.
For a lot of our customers, absolutely. They have global data, and if they, let's say they're going to go use uh, uh, maybe opensanctions.org data, which is global sanctions data. There's going to be scripts in there that you might not have familiarity with. You're going to go hire a linguist to go work on those. I mean, we just recently ran into some data in one of our data partners, and it's Burmese. That's not a very common script. We hired a linguist to go help us improve our Burmese matching.
So let's say I decide to use Senzing, and Senzing, by the way, for our listeners, has some kind of free tier, right?
Yeah, you can
Right.
download it for free without even an email address.
And you can use it up to a certain number of records, right?
Yeah, I think it's 100,000.
Yeah. So what about the cold start problem?
That was maybe one of the biggest breakthroughs for Gen 6 is out of the box, it typically matches better than humans. Now, let me tell you what that means. That means you're going to find a few things Senzing would miss, but Senzing's going to find more things that you missed. And that's because we've pre-trained it with these learning models, machine learning models on names, addresses, and these different comparators. And then we built in what's called principle-based entity resolution, where it by default has common sense. And then what happens is it statistically learns in real time to improve its performance. For example, passport's a great way to match. If you have the same name and passport number, let's say you have a loyalty club program and you're an airline. And one of the fields you get as the airline is the passport number. Well, name and passport number are great ways to match people. But what if the passport number is like, I don't know, 123, 123, 123? Senzing in real time learns that number maybe gets overused. Like maybe there's 20 people or 50 people that have that passport number. And even though out of the box it knows how to, use passport numbers correctly in real time, statistically it goes, oh, 123, 123, 123 is no good. And in that moment, it starts making better decisions in the future. And in that moment, it looks backward and say, man, did I make any decisions that I shouldn't have made, and fixes the past. So it has that real-time statistical learning as well. So yeah, hold boot, auto, then self-tune, self-trains, and it's explainable. It'll tell you why it put them together or why it didn't.
So briefly describe this notion of explainability. So what does that mean for the end user?
Well, our input and output is JSON. So excuse me, but someone else is going to make it pretty. Okay. People who build GUIs make it pretty, but you pass a message to our API that says, why are these two records together? And what you get out is a JSON that says, I'll tell you why. It found the record this way because the portion of the address was close enough I could locate the record as a candidate. And then the address is scored with this much confidence of similarity, and the names were this much. It was detected that it was Arabic in the culture, and then because of the Arabic comparison, then the score is this, and date of birth is this, and these things agree, these things disagree, and so it just makes it easy. And by the way, we just announced conversational AI for entity resolution, I think a week ago. Yeah, earlier last week. It is super cool this is an example of a combination with an LLM, is you can take that output JSON about why, and it packages that up into this beautiful explanation. Like it looks like somebody wrote a nice little report and gave you a paragraph on it. You can hand it to the compliance person or whoever, the auditor, go, why did it match or not? You just hand them a report. Yeah.
I was about to suggest exactly this because these LLMs are very good at reading code and they can interpret the JSON.
Yeah, we've done that. We have a ChatGPT plugin beta that's doing this right now. It's super exciting, the relationship between large language models and our AI for entity resolution. It's going to be peanut butter and jelly, man.
So you folks, Jeff, focus on what entities? So people
and companies. The hardest. So we've put the most effort into those. We've also been used for vessels, planes. Maybe somebody uses us for products.
Yeah.
But for each domain that you pivot to, you have to have comparators for it. So if you wanted to pivot to products, maybe the size of it, is it a 12-pack or a 6-pack? Is it black or charcoal? So those might not be, those are comparators that we don't ship out of the box. But Senzing as an entity resolution, I'll call it, platform is extendable and you can write your own comparators. So you can write a comparator for its size and weight and then do products.
And what does that entail, writing a comparator?
It's C or Java. I mean, we're a developer tool and it's a high performance engine. So you're going to write thoughtful code.
Yeah.
And what a comparator is you pass it two values and it passes you back, how it scores them and whether they're this same or the close or possible or it's not likely or there's no chance.
By the way, product is there's a huge need, especially if for all of us who use Amazon. When you search Amazon, it routinely spits out the same thing across multiple search results, right? It's very annoying. Right.
That's an entity resolution problem.
And you can't tell, is this, sometimes you even pass it, you think it's the product ID, it still doesn't return the right thing, right?
That's an entity resolution problem. And someday someone will build a few comparators and our engine will do products really well.
So again, for our listeners, right? So you can try to build this yourself, but you've got multiple problems. You got scale, and depending on your use case, scale and real time might be an issue, but accuracy obviously is an issue for everyone.
Multiple
right?
scripts.
Yep.
Different scripts. Explainability.
Yep.
Low latency, so you can answer questions as fast as at machine speed. You can't be waiting 1, 2, 3 seconds for an answer.
And then let's say you do all of this, then you have to maintain the system. So then who wants to do that? Right? So, I mean, you should be working on your core business rather than this system, right? So
you really end up with a team of people that on these entity resolution tech stacks that are homegrown, you really have to keep them forever because it becomes such exquisite knowledge and history, the institutional knowledge. You're going to have them for a long, long, long time. And we would suggest that these are smart folk and there's a lot of other more interesting things to do. By the way, do you think anybody's still working on spell check and grammar checkers? Like, oh yeah, you got a team working on spell check and grammar checkers. You'd be like, why aren't you using a library? That's what we're doing for entity resolution. It is crazy to have your own team work on it. By the way, if you're trying to get like scalable, real time, multi-script, explainable, privacy features, this, that, and the other thing. For like, I don't know, $1 million, you can get 70% of the way. For 5 million, you can get 80% of the way. For 30 million, you can get like 90% of the way. And I'll tell you, like 90% of the way is not even commercially competitive right now. People don't realize it's literally tens of millions to create an engine where you can add new data sources without having to re-engineer the schema every time. Hey, there's a new data source. Oh, we gotta have a big project. You want to be able to be elastically add new data sources. Just pour them in, new features.
So Jeff, as far as the models that are involved in a highly accurate entity resolution system, and by the way, you don't have to reveal all of your secret sauces here, but at a high level, is it mostly algorithms or is it a combination of rules, algorithms?
Well, it just depends where you look.
Yeah.
If you look in the comparators, it's models or heuristics like the Social Security numbers that are on the billboards, So the comparators are that way. In the past, we would have deterministic rules that would self-tune probabilistically. So you'd come out of the box knowing that names and Social Security numbers are great ways to match people, but then statistically learn that social is not a good social because it's whatever, 1, 1, 1, 1, 1. The breakthrough, though, was principle-based entity resolution, where instead of building rules around features, I'm going to take a wicked little turn here. I'll tell you what, I'll just take a shortcut here. I started meeting with people that study the hippocampus, okay? That does the entity resolution for humans, you know. If I ask you, you know, hey, that the movie Purple Rain, and artist, that name was a symbol. In your head, you know, your hippocampus is helping you find prints.
Right.
Okay. So I started thinking, how is it that humans do entity resolution? And I'll tell you what the field used to do is used to think about people and all the features about people, names and addresses and phones and dates of birth. And then you think about the features of companies, names and corporate ID numbers and fax numbers. And then cars, make, model, and VIN. So historically, you'd think about each of these looking up at them vertically. But what I did is I stacked a bunch next to each other: people, companies, cars, planes, routers, asteroids. And then I looked at it horizontally and I said, what is it, you know, for human cognition? What are there behaviors to features? And it led me to this thing called principle-based entity resolution.
And is this a mainstream idea, this principle-based entity resolution, or mostly you folks use it?
Oh no, that's just here.
Yeah.
Yeah. After 5 generations and 5 engines, and you know, I sold Gen 5 to IBM. It was kind of really the big discovery is that, you know, ask yourself the question, you know, how is a social like a VIN? How is a VIN like, you know, like a serial number on a router? How's it make and model like a date of birth? And it leads you down this path to behaviors. And so you could say it's deterministic, but instead of being tied to features, it's tied to behaviors. And so, you know, pick an entity, pick a router. A router has a MAC address, a make, a model, a color, a location, all of those features. You just describe 3 behaviors for each of those features, and you're done. You're done. I remember when my number 2, Jeff Butcher, called me while I was doing vessels. He didn't change any rules. He didn't change anything in the whole entity resolution system. He literally took vessels, which have things called IMO numbers. It's like a VIN number on a car. They have call signs. They have names on them. He just took the features of vessels and mapped them to these behaviors, and then that's all that was done. I remember him calling me and go, this is incredible. I'm now doing sophisticated entity resolution on an entirely new entity class with no new rules.
Huh.
I don't know if that was too abstract, you know.
And then, how much do you need to know about a new class of entity before you can apply some of these ideas?
I'll tell you the 3 behaviors. Okay, it's so simple. I can say tragically, the whole engine's so simple, you know, but maybe its simplicity is the elegance in it. Yeah. The first behavior is frequency. How many other entities, you have to say the word generally, okay? How many other entities generally have the same value? Like a VIN number. I'll give you 3 choices. Is a VIN number frequency 1? In other words, if you see a VIN number, it's generally 1 car, or frequency few cars, or lots of cars have the same VIN number. Which one's a VIN number for a car?
It's supposed to be 1, right?
Yeah, absolutely.
Yeah.
Right. Now, by the way, that's a great rule or a great behavior. But if it turns out because some operator was lazy or there was some error in some ETL job and a VIN number came through the same one on 500 cars, the system needs to learn that VIN number is no good, but the rest of the VIN numbers are distinct. But anyway, frequency is the first one. Then the next one is exclusivity. Exclusivity is, do they tend to have only one? Or can they have more than one? A VIN number, do cars tend to have more than one VIN number or one?
Right.
VIN numbers, date of births, by the way, are frequency many.
Yep.
Because one date of birth could be for many people, but it's exclusive. You tend to only have one.
Right.
And the last one is stability. Does it tend to stay the same over the course of a lifetime? Okay.
Right.
So a home address is a frequency few. It's not exclusive because you can have more.
Stable.
And it's not stable, right? So it's just we would call it an FM, a frequency few. Sorry. So that's what you do. You know, name an entity, and let's just describe what features describe the entity: height, you know, weight.
So for each of these features, you can kind of score them on these 3 things.
You just map those three behaviors. And so instead of having rules, you have a set of principles, and the principles are about combinations of behaviors. And it's magical. It literally allows you to introduce new kinds of entities, new kinds of classes, new kinds of features while the plane's flying. No schema change, and it automatically fixes the past, notices where the exceptions are statistically. You know, when I say generally, like that frequency, what's the frequency? When we teach it, we go, generally, how many entities have the same value? And then I give them an example for generally. Did you remember the first Pirates of the Caribbean? That lady's on the boat with the captain, and the captain's going to make her walk the plank. And she goes, I invoke rules of parley. Okay. Right, wait, she says it like a lady. I invoke rules of parley.
Yeah.
And then the evil captain goes, actually, those are guidelines. And that's the way this config is you tell it the feature behaviors, but then it watches the statistics on every feature in the system and goes, oh, that feature's not, that one value is not behaving the same way. And then it starts doing new calculations forward, and it uses that knowledge to fix the past.
All right, so we've established ER is super important. You can do something easy, hacky.
No,
you probably won't be able to match sensing on accuracy, real-time scale.
Yeah.
But a couple of other things I should point out about sensing. One, there's that free tier, so if you want to, you can try it.
Mm-hmm.
And secondly, once you decide, it's not super expensive, I have to say. And then another thing is it's flexible in the sense that you want an API, check. You want to run it in your own cluster, check.
Oh, but it's very important. Maybe it's a headline even is people just download the code and run it local. They run it on their environment. We don't have a host. If you want to run our API, you're running it locally in your infrastructure. You're running it on your cloud. You're running it with, you know, the elastically on AWS where it's auto scaling up, ECS Fargate, SQS queues, Postgres serverless, you know, scales up, loads 100 million records, automatically scales back down. That's all running in your, you know, compute environment.
Now, how do I know, Jeff, that this local piece of code in my environment is not sending some of my data over to Senzing?
How do you know? Yeah, static code compares.
But the reason I bring this up is last time we talked, you mentioned some new feature around encryption. Explain this to us.
Yeah, we have this. I have a few privacy features, and one of them is selective field hashing. So the data owner can one-way hash certain fields like driver's license, social security number, date of birth, and send those in the JSON structure, and then we'll still do the entity resolution on the hash. A more popular feature is application level encryption. You can have an encrypted database, but if your database administrator gets compromised, you're compromised your whole database, right? So application level encryption takes the individual features and uses your encryption key locally and then writes that encrypted feature to the database. So even a compromised DBA doesn't expose you to the risk of unintended disclosure of your data.
Right. So now, looking ahead, progress in tools in entity resolution. So I'm gonna kind of just throw out a few classes of tools, and you tell me what role they're playing now, if any, and if you envision they're gonna play a role in entity resolution moving forward.
Okay.
First is graph databases and graphs.
Oh, that's another, you know, peanut butter and chocolate kind of relationship. Graph databases are about connected data. Whether you have data in a graph database and you want it entity resolved, you'd pass it to an entity resolution algorithm. Or whether you want to take an entity resolved graph, like the output of Senzing, and populate a graph database. In fact, we have almost 100 projects in our GitHub that are all Apache 2 open source, including real-time replicators. One, for example, to a Neo4j graph. Is it conceivable that your core index that would run underneath an entity resolution engine could be on graph as well? Yeah, we've explored that some. We don't have something commercial on that right now. It's something maybe for the future, but definitely sourced from graph databases and published to graph databases. Absolutely.
Is that a long-standing connection or relatively new?
How long-standing, man? 3 years, 4 years, 5 years.
So that's not in the span of Jeff Jonas's career in entity resolution. That's not a long-standing connection, right?
Well, not over my 300 year. Yeah, I guess you could call it new, but the last 5 years, I'd say. But yeah,
So-
probably 20% of our partners are integrating our real-time entity resolution with graph.
So second class of tools and solutions, deep learning and neural networks.
I think those are real valuable, especially on the comparator side. I think
Happening now or more to the future?
No, I think the libpostal open source model is well, it's a regression model. Takes quite a while to train. No, that's all stuff you can use right now to improve comparators. Totally.
So why are people using them now or not?
Some.
Yeah.
Yeah.
And why aren't they? So in certain areas, obviously, deep learning and neural networks have taken over completely, language, computer vision. So why not here?
What I would say it's like our statistically learned library on 850 million names. It looks at the structure of the name and recognizes it's Arabic. It doesn't look for Arabic words. It just looks at the structure of it and goes, it's Arabic. And then it knows that bin and Hajj, then it knows it to classify it as culturally Arabic, and then use special comparators like bin and Hajj aren't part of the name in Arabic. So I think it's wide open to, you could do more there.
Yeah. The thing about deep learning generally is one, it's taken over areas where it's so clearly superior, so it blows away the competition. And two, the performance is acceptable, right? So
yeah,
in this case, does it blow away the competition, and is the performance or is it too slow, right?
Well, the problem is it's batch, and if you're involved in transactions in real-time business, you need real-time answers.
Yeah.
So the place to use those models is, where you can just refresh the model once every 6 months on, learning new structures of names, or learning. We just spent 1.5 years working on libpostal on that machine learning model to retrain it on 30% more, hundreds of millions of more addresses, so that new postal codes around the world are included in the machine learned model. So it belongs in, and it's very useful. I would like to see some more breakthroughs in the area of entity extraction. I don't know if you're getting to that next, but at the front door of something like Senzing, you have to announce what it is. Like, this is a name, that's an address. But if it's in unstructured data, extracting names and addresses, phone numbers, or whatever's in there, and then associate them to the right entity. This name and address go together, that name and address go together. There's not, we are the beneficiary and the victim of that upstream technology. You see, it's just between us, unstructured data, then entity extractors, then entity resolution.
So I've been playing around precisely with this problem using LLMs, and the results are quite good. But as you know, since they're LLMs, there's drawbacks: one, cost, and latency. So if you have a lot of things to extract, I don't think that will work. But if somehow someone can make it performant, maybe that's an option, right? So, but far from clear whether we can get to based on the requirements you have of millions or billions of things, it may not be performant enough, right? So.
Yeah, we definitely need, our part, not all of our partners, but our partners need thousands of transactions a second. They need queries in tens of milliseconds. They need full entity resolution, fix the past in 100 to 200 millisecond. And you'd be able to do that thousands of times a second on billions of records.
Wow. Yeah. Yeah. These are not viable solutions, far from them. So then the next one we already talked about, but I wanted to get your second take on this, which is vector databases and vector search. Seems promising, right?
It's intriguing to me. I'm gonna do some experiments with these as they come along. Our obsession with real time means we're gonna, wait till you got a contender in there that is updating the database in real time, and it's low latency. It's milliseconds.
So are there use cases or customers, Jeff, where it's not milliseconds, where you can see this some of these solutions play a role in the shorter term rather than waiting for some breakthrough? Or most of your use cases are really kind of in the
It goes like this. If you build a system that's batch, you can't grow it up and make it real time.
Yeah.
And so if you really obsess on real time, it turns out you can do batch all day long. You and I are streaming engines, but when we read a book, we're just streaming in a batch.
Right.
Streaming engines just eat batches left and right. So that's our focus, nothing less. And maybe 30% of our ecosystem that are using our tech are using batch infrastructure systems, but they appreciate the fact they could at any split second turn on and do data flows, real-time streaming data flows.
But in your case, you basically rule out anything that's not in the real-time streaming realm.
Yeah, I mean, we think for organizations to be successful, to be competitive, you need to make better decisions faster than your competitor. And if you're and 75% of our partners use us for fraud, bad guy hunting, clever criminals that don't use the same name and address on every record. They use 6 different names and 3 different dates of birth. And when you're chasing down bad actors, whether you're a bank or an insurance company or entitlement fraud or PPP loan fraud, doing your analysis and understanding who's who once a day or once an hour isn't good enough. Like, you really need to do it in the moment. They figure out what your windows are. We saw this back in Vegas, man. As soon as you change your window to once a day, they just start doing their little cheat, every 23 hours. As soon as you get it down to where you can detect it every hour, they just come in and do their thing every 52 minutes. So we're just trying to collapse that to close to zero.
So next topic, multimodality. So this means, you may need to resolve entities that, require some computer vision, some speech.
Mm-hmm.
Do you think that will be a requirement at some point?
It's just another comparator. If you wanted to add face, if you wanted to add voice, if you're trying to stop account takeover and you want to maybe introduce voice, you could just write if you had a voice comparator, you just plug it in. Absolutely.
Yeah.
That's just another feature, it's a biometric. Voice, fingerprint, face.
Same principle. What do you call it?
Just give it the 3 behaviors. You're done. Check.
Yeah. Which actually overlaps with my next topic. Once we get to the age of multimodal entity resolution, deepfakes. So now you not only need a comparator, you need some sort of fake detector besides a comparator, right? So it introduces a different kind of problem, right?
That is a very particular problem, isn't it?
Yeah.
Like when somebody presents themselves as you, or then presents themselves as you visually as well. Like somebody could do account takeover, they present themselves as you didn't have 2-factor authentication, and now they're you, okay? Now you have somebody now you have a voice comparator, and now they've cloned your voice. So they've just taken over more features. Now it's your face, right?
Yeah, or even just a voice, right?
Yeah.
So because most of what we've been talking about was comparing, but now it's also detecting.
Yeah, well, what happens with Senzing is we're only determining when there's a sufficient evidence to say that the same person is presented in the data record, okay? And we build the graph too, like relationships, but we don't do any scoring. We used to do the scoring too, but it never made us special. You know, red light, green light, score it from 1 to 10, good news, bad news. We don't do that anymore. So those are downstream systems. Visualizations downstream, scoring engines are downstream.
Yeah, by the way, so a lot of the modern things that I raised here, you know, vector search, vector databases, neural networks. I mean, it seems like scale and latency is going to be a challenge for a lot of these things for a while.
Yeah.
The graph databases seem to be more mature.
They're getting closer to the kind of performance that our bigger customers need, you know.
Yeah. And because the vector databases, they get excited when they get to 1 billion vectors, which might be nothing for you, right? So
that would be, I mean, you know, we have great projects that happen with 1 million records, but we also support organizations that have billions and billions of records.
but there's the latency requirements are so challenging, it sounds like.
You have to put a lot of work into that to get a high quality entity resolution at thousands of things a second on giant gobs of data.
And this is not Jeff, this is not a nice to have, it sounds like it's a must have.
Organizations that are trying to like give good customer service in the moment, your customer just on the web went on the website, just got completely frustrated. They just spent 15 minutes and they're fishing around. Now they've called your help desk. Do you know that was the same person that's calling in right now trying to get some help? Like, that's just higher quality care, you know?
Right.
Yeah. And in the fraud space, you know, I remember a credit card company created a new credit card for first timers, $500. They had people applying 118 times in a row. It's just, they would apply and it would say no. And then they would apply again and change 1 or 2 little things and would go no. But you ask enough times right in a row, boom, 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 then it says yes. You want to be able to, it kind of reminds me of, I did that when I was at IBM. I had this commercial on the Smarter Planet where I'm standing at the side of the road. And I go, how'd you know when to cross the road if you could only see how it looked 5 minutes ago? That's the way most organizations make decisions. Like literally, if you can't see what you're learning about your customers and getting a 360 view to understand them and you're 5 minutes behind, you're just all too often have the wrong advice, wrong recommendation, or miss the bad actor sneaking through. So
the class of new areas that I brought up, you know, are real but not ready. Now let's get to science fiction areas.
mm-hmm.
Quantum computing, Jeff, since you brought up IBM.
You know, that's too far out. I have nothing, no knowledge, no points of view.
Yeah. But it's not even
that.
Not even in the realm of we're considering it. Okay, so that's out. So what about, so here, this one is real, but there's no use cases and it's too slow, blah, blah, blah. Blockchain.
It's a tamper-resistant ledger.
Yeah. Write only, append only ledger, append only.
It's an append-only, tamper-resistant ledger, which has certain utility, but it gets overplayed on its overall utility. And I could give you a few use cases for it, but I'll just jump to what's happening right now, which is really amazing, is the breakthroughs in large language models and generative. The relationship between those and the ability to get to conversational AI for entity resolution, which
explain that to us.
Yeah, I want to decode that.
Yeah.
Conversationally, imagine just talking to your LLM and say, hey, you know, what kind of data sources are available out there in the public domain that I might be able to add to my system so I can get better visibility into understanding my customers. And it goes, oh, there's this, that, and the other. Oh, well, can you just grab that one and load it? Yeah, I'm loading it. Or yeah, I tried to map it, but
automation, basically.
Well, yeah.
Yeah.
So that's the operations of it, like finding new data sets, mapping those data sets, getting those data sets prepared. Why go chat with an ETL engineer when you could just chat with your LLM and say, hey, that's the business address, and that's the date of birth, and that date over there is the date of death. And can you load the records now? And it goes, yeah, the records are loading. And then you check in on it. So instead of a screen, this whole thing, we have to go to one screen and another screen and then find a checkbox and go over here. Why not just go, hey, what's the status on the load? It'd be very conversational. And then imagine conversational search. Who's going to want to type in, okay, Jeff, tab to tab over middle name, then type in Jonas, then tab over to the date of birth and pull down June, you know? There's just
So a lot of process automation, including for data operations, data engineering. But you already actually mentioned an example that's happening now, which is taking explainability, right? So
yeah. I can just we are envisioning now all the kinds of operations you can do around entity resolution are done conversationally. It's conversational config, it's conversational explainability, it's conversational search. Yeah.
so
And we're experimenting with it. We've got beta code getting posted on GitHub right now, all open source, so people can take our library and then go get use our beta ChatGPT plugin.
But how does this work? Because you pride yourself in, privacy, security, all of the, and then flexible deployments, right? So I deploy to my own cluster, and now you're going to call out a public API.
Well, I'll tell you what, you're going to use maybe ChatGPT only for like little examples and with maybe public companies that are just open source public data, right? But what you're really going to want to do is you're going to want to run it on your own private LLM. And I hope we have something maybe to share on that topic. Hey, how long till this little video comes out, by the way?
Probably like in 3 to 4 weeks. Yeah.
Hey, great.
Yeah.
Well, by then, I think we'll have some demonstrator code for LangChain, so you can use your own models, right?
Yeah.
So we're gonna produce. We're gonna just start priming our GitHub with open source examples that are demonstration code, so people can build and create their own conversational in-house using the tool chain that they want. But within that whole LLM, call it capability, they're going to have a truth serum on identity, and that's going to be Senzing. You're not going to use an LLM for who's who.
Yeah. And so you're excited about this because you think that these are real, they'll solve real problems. You're not doing it for fun, in other words.
Oh no, the future is coming. And the future is going to be people more conversationally engaged with compute.
Yeah. No, it's happening now. Yeah.
It's happening right now. In fact, if organizations aren't incorporating this into their own internal workings and thinking about how it relates to their products, they're falling behind, man.
So you talk to a lot of CXO. So is one of the first things out of their mouth LLM?
It's in every conversation.
Really?
Yeah, it's 100%. Every single conversation I'm in.
Yeah. It's what do I do, basically?
At least 20% of the folks I talk to tell me how they're using it in their own life or in their work, in their job.
Yeah. And these ran the gamut, right? So some are in really highly regulated industries, so they tend to be more careful about what they do.
Well, here's my test. I think there's a lot of folks overestimating what they do, and they're going to use them the wrong ways, and they're going to get, I'll say, schooled. I think the rule of engagement, my best litmus test at the moment is, if it gave you a different answer tomorrow, is that going to be a problem?
Right.
If that is true, then you're not using it the right way.
Yeah. Set temperature equals 0.
Right. Yeah. 0.01 is temperature.
Yeah.
But then it's not going to have the creative qualities that you're going to want. Right?
Yeah.
So,
by the way,
in explainability, what happens in the inserted conversation, you get the explainability out of the JSON out of Senzing, and you get the values and the scores, like here's the 2 addresses, here's the score. The qualitative thing that's wrapped around it is the narrative. That narrative can change. It just says it one way and it says it another way, but it's all qualitatively saying the same thing.
Right.
And it's beautiful and convincing. But those are the addresses and those are the scores. Those were inserted.
Right. By the way, so one of the we're wrapping up here, but one of the things that you mentioned that I really I'm seeing is this need for companies to start having a strategy around custom LLMs, right? Because not every company is going to be comfortable using these public APIs.
That's 100%. And how are people gonna, what data are gonna be in those LLMs and what training did it have? And what's the openness on what that training data was? But to the extent that you use them qualitatively, it does take some heat off because you're not trying to, exert truth on it. What is the truth of it?
Yeah, but I mean, on the one hand, it's great to exist and you can experiment, but you have to be careful about how you experiment. You don't want to send it some information that might move your stock price.
Yeah,
these,
second order effects. The second order effects is going to be fascinating.
yeah. I mean, so I don't know what CIOs and chief security officers are doing around staff just hitting these chat AIs with who knows company kind of questions, right? So
Data leak protection, DLP. Do you know the term?
yeah.
Yeah. I mean, imagine DLPs. They're going to need to be running on all the prompt engineering your organization's doing, right? All the queries that you're dropping
So
in.
one solution around this, obviously, is if you have your own custom LLM, just in-house. Right.
It's not, it won't be just so easy because
Yeah.
there's things that you're saying in HR that you're not going to say to everybody else,
That's true. Yeah.
right? And you're going to have other things in corporate security where they're, looking at some insider threat matters that you can't expose either.
That's true. Yeah. Because
So the governance piece is going to be along a tall hill, okay? But people will figure that out.
yeah. Governance and lineage and auditability, right? So, I mean,
Yeah. Oh, by the way, that's another reason why LLMs aren't going to come around and do entity resolution anytime in a hot second because there's no lineage.
yeah.
In privacy by design entity resolution, you can get lineage on every single record. You know where every record came from, its source system, its transaction.
Yeah.
And by the way, GDPR and CCPA, the privacy laws, atomic delete. If you need to, for privacy reasons, delete one record, you need to delete the one record and then restate the entity resolved graph as if the record didn't exist. You don't want to have to be rebuilding your whole model with a 1 week build.
Right.
Because you deleted one record, there's going to be a carbon problem.
Right.
Too much energy to be consumed.
Yeah. No. So this is great. Thank you, Jeff. Always fun to talk to you. And for those of you who haven't checked out their website, it's Senzing, SENZING.com. Thank you, Jeff. Yeah.
Good.